Okay, hello everyone. So for this video, I will discuss some of the problems in probability and statistics. So the outline of the probability and statistics topic, we have a lot of topics to discuss. But yeah, so we have the counting techniques for probability, so the permutations and the combinations, and then the probability of events, so the loss of probability and the binomial distribution. So for statistics, we only have a basic measure of statistics, which are descriptive statistics and also Venn diagrams. Now we'll also discuss that in this video. So let's start with the first problem. So how many permutation can be made out of the letters of the word engineering? So we have this problem and we want to know how many permutations of this word is possible. So how do we do this? We have the general formula for finding or for counting this. No? So the general formula for that is we have the factorial of n over the factorial of p, factorial of q, and so on. Ano? So if we have this word which has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 11 letters in this word. So therefore, yung n natin dito is 11. So we have n is equal to 11. And then we will count for every word or for every letter in this word, we will count how many letters in this word are. So let's say for E, how many E are there? No? So we have 3 for E. For N, we have 3 as well. Okay, and then for G, we have only 2 G's. So G, and then for I, we have 2 I's. And then for what else? No, we already counted N and E. So last one is R. So we only have one for R. So this will be the last one. So to find the permutations of this, we have 11 factorial over 3 factorial, 3 factorial, 2 factorial, 2 factorial, and 1 factorial. Sorry, 1 factorial. Okay, so let's input this in our calculators. So we have here 11 factorial. So we're going to 11 factorial. So the factorial is here. And then 3 factorial multiplied by 3 factorial multiplied by 2 factorial multiplied by 2 factorial. And then actually you can omit just the 1 factorial now. So since 1 itself can be cancelled out. So I just forget about that. So we have 2,000 or 277,200 as the number of ways, no, to permutate this number or this word. Okay. Okay. So for the next one, so if 3 coins are tossed, how many possible ways are there of at least 1 coin showing tails, at most 2 coins showing heads? No? So if you do not have any idea how to do this, you can just count this manually. Let's see how can we do this using we call this. Actually, it is a tree diagram, no? So let's say we have a coin. So the first coin, it could be either a tail or it could be either a heads, right? So let's say we start with the tails first, no? So the first coin is tails. So after we toss another coin, it can either be a tail again, so 2 tails, or it could be either a tails and a head. And then for the third coin, no? So if we toss it again, let's say it becomes 3 tails. And then for the other case, it could be a tails, tails, and a head. So for this one, we have, let's say it will become first a tail, and then it might be also 2 heads. So for the heads also, if the first outcome is heads, or for the first coin it is heads, so it could be either a head or a tails, right? Sorry, it could be either a head, tails, or it could be head, head, no? And then for the third coin, it could either be head, tails, tails, or head, tails, heads, no? And then for the last one, we have either a head, head, tails, or a head, heads, heads. So we can count how many possible cases we have here. No? So we have 1, 2, 3, 4, 5, 6, 7, 8 cases. But we are only interested in the first, no? So the first question is at least one coin showing tail. So meaning if we say at least one, it should have at least one tail or two tails or three tails. No? So we can count here how many of this has at least or have at least one tail. So we have three tails here. So it is counted. We have two tails here. It is counted and so on. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 as our answer, you know. So that will be how you will solve this if you forgot, no? How to do this. And we only have a few coins. And then for the second one, we have at most 2 coins. So meaning when you say at most, it will start from the lowest. So it has at least one coin, no? So we have one tail, no? Sorry, one head pala, no? One, at least one head, and then or two heads. Okay. So how do we do this now? So how many of this has this exact same thing, no? All right, so we have here 1, we have 2, we have 3, 4, 5, 6, and 7. Sorry, at most lang pala, no? So we only have 6, no? So the answer here should be 6. Okay? Okay, now, so how do we calculate this if the number of coins, let's say we have 10 number of coins or so on. So if we have a higher number of coins, okay, it will be much harder, no, to investigate this manually. So the technique here, we have a technique to find this count or to count this possible ways. So we have just a summation of n, combination of r, sub I, no? And usually yung n natin is the number of tossing, no, or the number of coins. The r here will be what we are investigating. So if we have only, let's say, one tail, so r is equal to 1. If we want to only observe exactly 3 tails, so this should be 3. So let's say, for example, for A, this will be equal to the number of A's, no? Is we have 3 coins, combination of 1 coin or 1 tail, and then plus we have 3 coins, combination of 2 tails, plus we have 3 coins, combination of 3 tails. So if you input this in your calculator, this will be, we have 3, C, no? So combination here, and then 1 plus 3 combination 2 plus 3 combination 3. Yeah. So the answer should be 7, no? And then for letter B, you will also do the same thing. So at most only 2. So we have only R as equal to 1 and R is equal to 2. No? So this will be equal to 3 combination of 2 heads plus 3 combination of 1 head. Or this can be commutative, no? So the answer should be, let me delete one of this. Okay. So the answer is 6. Okay, so there is a short or manual method and there is a shortcut method using the concept of combinations. Okay, so another example here. So we have what is the probability of picking an orange and a white ball out of a bag containing 7 orange balls, 8 green balls, and 2 white balls? Okay, so let's visualize the problem. So we have here a box. Okay, we have a box here, and portion of the box we have orange balls. So how many orange balls do we have? We have 7 orange balls, and then we have 8 green balls. So the green balls are 8, and then the white balls are 2. So in total, no, the number of balls in this box is 7 plus 8 plus 2, which is 17. Ano? So the question here is, what is the probability of picking an orange ball and a white ball? So this will be just the numerator, the denominator. Numerator is the case wherein we will pick an orange ball and a white ball consecutively. and then over the total number of balls, no? Yun usually na natin. So, how do we do this? No? So, there are actually two cases here. And if you observe, no, let's say we pick one here. So, let's say you pick an orange here. After that, the number of balls will reduce, no? So, let's say you pick one orange, this will become now 6 orange only, no? Or in other words, this will only be, no, the total number of balls will be only 16 after you pick one ball, no? So, we have to consider that into our calculations. So, this is actually a joint probability, ano? So, for the first case, considering as well yung vice versa na mangyari, no? So, let's say you pick an orange ball first and then a white ball, or another scenario is you might pick a white ball first and then after that an orange ball. So, if you pick an orange ball first, so we have 7, no, the total number of orange balls over 17, and then after that you will pick another ball, no, for the second picking. So this will be how many white balls? We have 2 white balls. And then what remains, no, how many balls remain? We have 16 only. Okay. So this will be your case wherein we pick an orange first. Sorry. Orange first, then white. No? And then for the other scenario, since it could be orange first then white, or white first and then orange, so this will be white first, so 2 over 17. So you will pick a white here first, and then for the second case, you will pick an orange. So this will be 7 over, the total is 16. So this will be white first, then orange. So calculating this, we will have an answer of 7 times 2 over 17 times 16 plus 7 times 2 over 17 times 16. So we have 7 over 68. Or we have 0. So you can write the rational form. So rational form. Sorry. 7 over 68. Or 0.1002 9. Okay, so that will be your answer. Okay, next one. So what is the probability that either 2 heads or 3 heads will be thrown in 6 fair coins if 6 fair coins are tossed at once? No, if I think this is if, no. So you can also do a diagram of this, but that will be time consuming. So what can we do here is we can utilize the counting technique that we utilized in the previous problem. So as you can remember, we have the NCR, right? You can use this one. And how many pair coins are tossed? So we have N is equal to 6. And we have no, so exactly 2 or 3. No? So kindly remember as well, if you have or, okay, we are adding. No? Usually we're adding the probabilities. If we say and, we should multiply. No? So remember this. No? If we say or, we should add the probabilities. If we say and, we should multiply the probability the probabilities or the number of cases. No? So if n is equal to 6, then we have r, no, is equal to 2 and 3. So we have 6c. So c2 exactly 2 heads, or exactly 3 heads. So we have 6c3. And then over what? No? So we're talking about probabilities. So what is the total possible ways that this can happen, o yung combination ng 6 pair coins? So this will be actually just 2 raised to 6. No? So you can imagine it will be just, let's say, T and let's say T or H. So it will just multiply by 2 every time. No? You can see the trend, no? So this trend will be this form, ano? So if 2 is equal to 1, 2 squared is this, and then 2 cubed is this. So the number of coins will determine the number of possible ways. As you can see here, we have 2 only, we have 2 squared, and this will continue and so on. So the answer here is a calculator will be C3, no? C over 2 raised to 6. So the answer should be 35 over 64, or in rational, or sorry, in decimal places, we have 0.5469. So this will be your probability, no? So 54.69%. So two die are rolled, find the probability that the sum of the two die is 9. Okay, so in here, this is kind of trick. I think this is easier if we do this manually, you know? So we have two dice, no? Two die or two dice. So what is the probability that the sum of the two die is 9? So what are the cases that it will have a sum of 9? So the die is only constrained into 6, no? So we have only 6 values there, which is 1 to 6. So a first combination of that will be, let's say, 6 and 3. So 6 for the first die and dice, and 3 for the other dice. Or it could be vice versa, no? So we have 3 and 6. Or it could be 5 and 4. Or it could be 4 and 5. Okay? So this will total into 9. So therefore, we have four ways that it will add to 9 yung kanilang sum, no? And what is the total, no? So if we have here 4 as our numerator, what is the denominator? So we have 2 die. So therefore we have we have 6, no? So 6 possible per die. And then we have 2 dice, so this should be 6 squared. So we have 4 over 36. Simplifying this is 1 over 9. Wherein 1 over 9 is 0.1111, no? So this will be your final answer. Okay? So let's move on. So two students are working independently on a problem. Their respective probabilities of solving the problem are 1/3 and 3/4. So what is the probability that at least one of them will solve the problem? Okay, so we have a law in probability wherein we want to figure out what is the probability of event A or B from happening. So if we have U, no, we have union, we have or, no? So we have U means, oh, this is actually a cup, no? We call this cup in mathematics. So U means either or, no? And usually we incorporate this by adding, no? Okay, so to find this probability of event A or B happening, this will be just the sum of A, or the probability of A happening, and the probability of B happening, minus the probability of A cup B from happening. So meaning the probability of A and B happening. So if we have this symbol, which is actually, we call this the cap, no? So if this is the cup, this is the cup, this is the cap, no? So we incorporate this with N, and we usually multiply, now incorporated by multiplying two probabilities, no? So what is the P of A and P of B? So we have already given here P of A and P of B. So this will be just 1/3 and 1/4. Sorry, 3/4. So what is the probability, no, or the case wherein they solve this problem together? So we should multiply them, no? It is that simple. So we have just 1/3 times 3/4 to incorporate this as our the probability that A and B will happen. So this will be equal to what now? So we can just use our calculator. So we have 1/3 plus 3/4 minus we have 1/3 times 3/4. So we have 5 over 6 or 0.833. So we have 5 over 6 or 0.8333. Okay, it's that simple. Next one, so a cat has a litter of 7 kittens. If the probability is 0.52 that a kitten will be female, what is the probability that exactly 2 of the 7 will be male? So for this problem, we have two cases. Now, actually, with our previous problems, we can actually utilize if it only has a failure and a success, we can use the binomial distribution for probability. So what is the binomial distribution? So the probability of R happening is equal to N combination of R times P raised to R and then Q raised to N minus R. You know? So what is R here? So R here is the success rate. Okay, to take note that R is the success rate. Sorry, not the success rate, but the number of the probability, no, or the number of, you call this, I forgot the term, no. So for this case, we have let's say 2, no. So the number of combinations that we are interested in, and then we have P as our success rate, okay, and then Q is the failure rate. So it has a relation, this success rate and failure rate has a unitary relationship. No? Ibig sabihin, if we add this P and Q together, this should be equal to 1. So for this problem, what are the R, P, and Q to solve for this? Actually, I also have N, no? So N here is the total number of possible or the number of, I forgot the term, no? But N here is 7, no? So the number of kittens or the total number of kittens is 7. And then we are interested in the probability that exactly 2 of the 7 will be male. So R here should be 2. And take note that this should be male. So therefore, the success rate is the success rate that it will be male. Therefore, if this is given, which is the probability that it will be female, so it will be female, ano? So therefore, the probability or the success rate that it will be male should be the unitary, no, difference of this. So it's 0.52. So this should be 0.48. No, to take note of this. So the failure rate will be 0.52. Okay, so plugging in these values to our formula, we have 7C 2, and then P, so we have 0.48 raised to R, so R here is 2, and then the failure rate is 0.52, and then raised to N minus R, so 7 minus 2. So the calculation will be, we have 7C, 7C, where's C2, times 0.48 squared times 0.52. So this will be just 5, no? So 7 minus 2 is 5. So the answer should be 0.184. So this is the probability that exactly 2 of the 7 will be male. Ayan. Okay. So moving on, okay, so we have statistics for this problem. So for the given numbers 4, 6, 8, find the standard deviation. So pag hindi sinabi, no, usually yung population yan, standard deviation of the sample, and then variance of the sample, and then the RMS value. Okay, we want to manual calculation here. I'll just show you how to do this using your calculator. So for letter A, okay, I think in general you will utilize this. So for stat, no, so the mode for stat is mode 3 and then 2. So actually you have different stat uh, modes, but we will only utilize the 2. Usually this is the linear regression mode. So mode 3 to lang usually, ano? So we want to input the 4, 6, 8. It depends on you where do you want to put the 4, 6, and 8, or which column will you input this 4, 6, 8. Basta take note of that variable, ano? So let's say I want to input this 4, 6, 8 in the y-axis or the y table. So we have 4, 6, and 8 here. Okay, so I'll just input here. So I could make this x is equal to 0 or whatever value I want to. It won't be important really for this problem, no? So after you input this 4, 6, 8, it doesn't matter what are the values of x, since it won't be part of the computation. Okay, so press AC, and then we can use this mode. So shift 1, and then we have the variable, so 4. And then for the values here, so let's break this down first, no? So what is n here? So n is the number of data points in the table. X bar, or yes, X bar here is the mean arithmetic, or the sample mean. Actually, we just have one mean, no? So the arithmetic mean of the data, we have here sigma x. So sigma x is the population standard deviation of the x variable. And then 4 here is the sample standard deviation of the x variable. We have y bar, which is the mean of the y table, no, or your column. And then we have sigma y, which is the standard population standard deviation of the y variable. And then sy is the sample standard deviation of the y variable. No? So you can explore this one if you want to try. No? Okay, so for the standard deviation, we only have this as a population. So therefore, this should be sigma. If it is a sigma, then it is the population, diba? So the sigma sub y, the y variable, we just calculate here, we just have 6 and then equal sign. So we already have a value which is 1.6330, no? For the sample standard deviation, so this will be just S of y. So again, do this. So shift 1 and then variable 4. So sy, or the sample standard deviation in y, 7. So we have value of 2. Now, if we want to find the variance, so the relationship of variance, no, it is just the square of the standard deviation. Therefore, the square of sy is equal to, so 2 squared is equal to 4. So what about the RMS value? So the RMS value is equal to the square root of the sum of the squares of our values. No? So for this case, I'll just input here y. Since the variable that we use is y, so we can just put here y. And then all over the number of data points. So can we utilize a calculator here as well? So actually we can, no? So using your calculator, you can also find here. So shift 1 again. And then we can see here a mode in the stat. No? So we have here sum. So we can find the sum, we can find the arithmetic sum, the square sums of the variables, the product of the variables x, y. We can also find the x cubed, no? The sum of the x cubed, or x to the fourth. Okay. So we are only interested in square of this of the variables or the data set. So we are interested in either 1 or 3 here. So since we input the values in the y table or the y column, we will use 3. So this is just the first, no? Ito lang yung nakuha natin doon. Sorry. We only got this one. So we want to also divide this by n. So n here, how many data points? So we only have 3. And then don't forget to what, no? So this will be what, no? So find the square root, diba? So find the square root of y squared over 3. So this will be equal to 6.2183. So this will be your answer, ano? Alright. And then for the last one, we have a survey of 10 smokers. It was disclosed that 7 smokes M and 5 smokes H. So 3 smokes W. It was further disclosed that 3 smokes M and H, 2 M and W, 2 H and W, 1 M and H and W. So how many smokes M only, smokes W only? How many do not smoke any of this? Smokes M or H but not W, smokes M and H but not W. Okay, so how do we do this? So we have a Venn diagram to help us understand this problem. So let's first enumerate the given. So out of 10 smokers, so we have a total, no, a universal set. Total of this universal set that we have M smokers, no? And then we have H smokers, which is 5. And then the smoker of W is 3. And then it is further disclosed that 3 smoke M and H. So if we say M and H, this will be the intersection of M and H. No? So we have M and H, no? Which is 3. And then we have M and W, which is 2, and then we have H and W, which is 2, and then M, H, and W, which is 1. Now, how do we do this? So we have a Venn diagram. We can imagine this as a universal set. And then we have three categories. So we have M, we have H, and we have the W here. Yeah. Okay. So this will be, let's say, for the M set, the H set, and the W set. So how do we do this? Now, we will start actually from here. So we will start with the middle. Usually, if this is given, then we will start in the given wherein it is an intersection of all these three. So we have one here, ibig sabihin, no? There is one smoker that smokes every or any of these three given brands. So this will be one, in the center or the middle. And then, okay, so we have already utilized this information. So we can also determine the set here, which smokers smoke the brand M and the brand H. So we can see that this is the portion which smokes M and H, as you can see. So therefore, the total of this intersection should be 3. Therefore, if this is 1, then we should input here 2, di ba? Okay? So we utilize this information. And then for M and W, so for M and W, this will be your intersection. So the total is 2. Therefore, this should be 1. So that this will be a total of, this will have a total of 2. Same for H and W. If we have this portion, if we have 1 already here, then this should be 1, right? So that the total will be 2. And after that, we can now move on to this portion. So the 7 smokes M. So we already have 4 smokers here, as you can see, enclosed by this M circle. So therefore, we have 3 here to have a total of 7. So 4 plus 3 is equal to 7. And then for H here, so we already have here 4. So therefore, there is only 1 smoker that smokes H only. Okay, and the last one, since we have here given 3 as an intersection of this, so a total of W is 3. So therefore, there is no person who smokes only W. So this will be your Venn diagram for this universal set. Although, we have to check first if the total here is equal to 10. No? So there might be no smoker, or there might be smokers that doesn't smoke M, H, and W, meaning it might smoke a different brand. So the total of this, we have 3, 2, 1, so 6, 7, 8, 9. So we only have 9 in the Venn diagram. Therefore, there is 1 that do not smoke M, H, and W. So to answer for letter A, so the A, how many smokes M only? So only 3 smokes M only. How many smokes W only? So W only, we have 0. How many does not smoke M, H, and W? How many does not smoke? So does not smoke M, H, or W. No? So we have 1. How many smokes M or H but not W? M or H. So we have M or H but not W. So we have to remove this. No? So we have 3 plus 2 plus 1, which is 6. And then last one, so how many smokes M and H but not W? Sorry, M or H but not W. Yes, okay. Okay, I get confused now. So we have a difference here, or an N. So how many smokes M and H but not W? So if we say N, we are talking about the intersection. No? So this is the M and H, diba? So we have 3, but not W. So therefore we should, so if this is the M and H, we have to remove this H portion. No? So the total will be only 2. So that will be all for this video. So good luck and see you in class.